if you're doing a -40 installation, as an example, and you're using ammonia, you're going to be running under vacuum. If you are 100 feet away and you're trying to bring back a mixture of gas and liquid, it's going to cost you something, which is
Yeah.
called a pressure drop. You're already running under vacuum. You're trying to bring that back to the mechanical room. You need to run your compressor way lower in temperature just because of that pressure drop. If you're losing 3 psi when you are already under vacuum, it's going to cost you money. If you do that with CO2 and you're running at very low temperature, but your suction pressure is 200 psi and you're losing 5 psi, big deal. You know what? Big deal. You just lost 0.6 degrees.
Huge. Welcome to the Refrigeration Mentor podcast and CO2 Mondays. I'm your host, Trevor Matthews, and today I got a returning guest, good friend of mine, Benoit Rodier. Super excited to have this conversation because Benoit is deep into the industrial CO2 applications, and this is what he does day in, day out. We've talked, we learned about Benoit, and today we're just going to be diving into more of the applications, CO2 applications he's been involved in. So if you have any questions, please put them in the chat. If you're listening to a podcast and you want to learn more about what Benoit does and his company does, Cimco Refrigeration, please reach out because we really want to help. And this is why we do this week in and week out, and why Benoit and friends of mine always come here to really share this information. And I have more and more requests for the industrial side, and he's an expert in that. So Benoit, welcome to CO2 Mondays. How you doing?
Very well. Thank you, Trevor. How about you?
Oh, so good. So I really want us to dive into more on the industrial side, CO2 application, because a lot of times we're talking about the commercial side. And I know CO2 is going to be a pretty big player in the industrial. It already is. It's not going to replace ammonia, but there's applications I know for sure that CO2 may be a better option. And I'd love to talk about some of those options as well, just to give everyone a good idea on where, when they're doing a project, maybe they should consider CO2. So let's dive into some of the different applications, ammonia versus CO2, and maybe some of the benefits of each.
Trevor, it would be great to do that, but I would like maybe to take 2-3 minutes just to come back on the last time we saw each other. That was in October, correct?
Yeah.
I think we need to take just a few minutes on that. You know, we were in Germany at the Chillventa show, and it's not my first time. It's not my first visit. And you know, walking in those 9 or 10 major like conference exhibition, you know, floor in various spaces. What I saw last year, 2022, compared to when I started maybe 10 years ago, and I would like to have your opinion as well. It's like such a tremendous movement towards new technology. And it's not even a question for them where the future is going. Okay, everything that was lying on the floor everywhere were CO2, propane, majorly. My read on it, okay, was like 80-90% CO2, ranging from small condensing unit for your own home application. Mitsubishi, and I don't want to give name, but Mitsubishi CO2 small compressor about that big. That's the one I remember. And going all the way up to rack of 10, 15 meter long into section in some of those booths, you know, using CO2. Was that your impression, Trevor?
Oh, totally agree. And like, there's so many people reaching out to me from CO2 Mondays that are making like 1 kilowatt, half a ton unit, condensing gas cooler unit. I don't know what to call them, if I should call them gas cooler units or condensing units, but there is so many residential, like I thought, oh, CO2 is not in residential. There are so many applications around the world with CO2 in residential, like water heaters and things like that, and heat pumps are coming. So I totally agree with you there. It blew me away. That was the first event I've been to for Chillventa, and it was almost all natural refrigerant. There was the odd, like, you know, synthetic refrigerant, but definitely 80-90%. And what was cool about that, probably like you seen, is that it didn't matter what tonnage it was. It wasn't industrial. It wasn't, you know, small, like, it was everything.
Yeah.
So it was really cool.
Yeah, no, I agree with you. Your take on it is like, don't even ask me, do you do 500 kilowatt or do you do 2 megawatt? It's not even a question you should ask. It's like when you need it, kind of, you know?
Yeah, no, exactly. And now like I still have people talk to me and we have questions about, well, it doesn't work. It's inefficient in warm application, warm ambience. That's all worked out. Like all that stuff, but depending on where you're at, you're going to design a different system. You're going to design a different system here in Canada compared to maybe South Africa, but there's options and they're there. They were at Chillventa for sure.
Yeah, that was quite impressive. That being said, you know, to dive a little bit today into industrial refrigeration, as you know, our company has been doing big industrial installation for over 100 years. And we always been ammonia. We were R22 many, many years ago for ice rink, but we were majorly ammonia. And 10, 15 years ago, when I started going to those places, meeting mostly European manufacturer, it was clear in my mind that it was going CO2. And Trevor, the number of people that told me North American, it will never get into the industrial bit. You know, you know, this is for supermarket. Okay.
Yeah.
This is what I was being told. And in my mind, it was like, you know what? I don't know. It feels strange. I have really the impression that eventually we're gonna get there. And I guess we're lucky that in Quebec, people start to believe in it. And not only did they start believing in it, we had like 3, 4, if not more, manufacturers that start building their own CO2 rink. And at the beginning, it was for supermarket. That was really the trend they were taking. That was the market that was calling for it. This is where people learn about CO2 majorly transcritical system in the supermarket industry. Now, if you look at the picture today, most of those manufacturers going to tell you, yeah, we still manufacture supermarket equipment.
Yeah, every size. Like now, I really recognize this actually quite a few years ago when I was working with the manufacturer and I was doing CO2 training for them. In Ontario, here, we have a highway that goes across the province, but there's en routes. You can stop at these en routes, and they usually have these little Coke machines or pop machines where you can go grab thing. And then I'm looking at the tag and it says R744. I'm like, what? In these little tiny uses, and that was years and years and years ago. Most people don't know that there's so much CO2 out there, even in little small tonnage systems, all the way up to these megawatt systems.
Yeah. And the megawatt system, I wouldn't say it's new, but it was never really on the table. And even from myself, I remember the very first project where I started thinking about why don't we do it CO2? And one of the reasons going that way, I remember at least the very, very first project we did. The owner had a system where he was renting the space, maybe with 50 rooftop unit all over the place, going from R12, 502, 22, 507, 404. He had everything on the table. And he was building a brand new plant across the highway, and he was looking for a solution. And to be truly honest, I was not sure that a CO2 system was capable of doing that at that time. We're talking about 500 tons of medium tension. And again, this is like close to 10 years ago. Most manufacturers were giving you 40, 50 ton transcritical system for supermarket. So I thought the gap was pretty large, pretty huge. And based on my own personal experience, I said, I would like to try CO2, but I'm not sure about going transcritical. So basically, I took what we knew and we got the team on board, and people were so comfortable, but everybody really worked hard. They learned, I wouldn't say everything about CO2 because there was a lot of trial and error. Yeah. But, you know, we decided to do it together, and we went with an ammonia-based system in one mechanical room, 2 screw compressor. And then we decided that we're going to do a brine CO2 system. Now, to make sure everybody understands is when we say brine CO2 system, it's like doing a water chiller or a glycol chiller. Except then circulating glycol water, we are circulating CO2. So no CO2 compressor, no gas cooler, strictly a CO2 cooler and a CO2 pump. And the main refrigeration system is an ammonia system. So we had to learn the CO2 cooler, which is actually called a Cascade heat exchanger, where we have ammonia on one side and CO2 on the other side. And the other thing we had to learn was actually to recirculate CO2, so to pump CO2 throughout the plant. So some of the key learning we got out of that experience, the first thing was like doing an ammonia system for us, we could do it like that. That was a no-brainer. Then we went with a shell and tube Cascade cooler, and the sizing was done by people that really knew how to design and size heat exchangers. So that was also a no-brainer for us. Then it's all the question is like the pumping unit, because you cannot just take the CO2 and pump it through the plant. Well, actually, it's quite similar. If you're pumping glycol, you might have a small glycol buffer tank, and you pump it to the plant just to make sure you match the flow and the hydronic loop dynamic. Well, it's the same thing with CO2. You need a CO2 tank, and then you take it and you pump it through the plant. So how large is the tank? Where is the pump? How much flow do we need? What is the height that we need? What is the horsepower of the pump? Where can we find the pump? What's going to be the line sizing? All this because it was not in North America. And the very few people that did it, you phone your competitor, hey, do you want to help me out? He's not returning my call. So I went to see one or two installations in Europe. I've seen a big cold storage site in Denmark, fully automated. It was running at minus 30 CO2. I saw the CO2 pumping system, and when I looked at it, I said, you know what? It really looked like an ammonia pumping vessel, except that it was way smaller, way smaller. And the pump was way smaller as well. And the horsepower of the pump was way smaller. And when you look at the pipe going through the plant, it was way smaller as well. So I think that was the start of a long journey where we have done many projects this way.
Yeah. And I think that is the key. Like, you have been developing and learning for years. And I like the way you said it. It's a journey, because I believe we're just in the beginning of the CO2 journey, because you've been doing it for 10, 15 years. Other people have been doing it for over 20. Compressor manufacturers, valve manufacturers, controller manufacturers like Microthermo, years and years. But I think right now we're at a point where the journey is starting to begin for the masses. And I'm really thinking that we're on our journey to showing the world that CO2 is a player in all different applications. But you have to respect the different locations, the different equipment, the safeties of it. And this is all stuff that is learnable. These are all learnable skills. So anyone who says, oh, it's high pressure, well, it's a learnable skill to understand that, yes, it is a high pressure, but if you learn how to work with it, it's going to be a great solution for a lot of different applications.
Absolutely. And also, we have to keep in mind the regional reality of where you are. And as an example, I've been in Japan, and I went to see many sites, many installations, and the technology is incredible. They've tried everything. There's a lot of really, really good suppliers down there. Just taking a train, which is going at 350 kilometers an hour, wakes you up, okay? That's the very first thing. So you go see refrigeration system with the same technological advance, they do it. But the difference is like, they have very small plant. When you move in Europe, it's the same thing. They have tons of location, they have tons of plant, they do really interesting application. But again, the small of most of those installations are fairly small. When you get in North America, Canadian market, and more importantly, the US market, and you walk into a place where it's like 1,000 feet long.
You need a car. You need a side by side to drive through it.
Yeah, exactly. You need a golf cart to go from one end to the other end, and you look at the mechanical room, and you don't have like a 200 horsepower compressor in there. You have an 800 horsepower compressor. Or if we go out west in Canada, in Winnipeg and Alberta, some of those pork plant facility or French fries facility, and you walk in the mechanical room, Trevor, honestly, you're like, wow.
Unit after unit after unit after unit of hundreds and hundreds of horsepower, hundreds and hundreds of tons per unit. And there's many of them, dozens of them.
Exactly. So knowing that you've seen some transcritical system, which are 15 feet long, and it could do the job, and then you look at those mechanical room, you're wondering, are we going to bridge that gap? That being said, I'm a true believer of CO2 refrigeration. And the nice thing about it, we have so many options on the table, and it keeps on improving. So one of the very first solution, it's a transcritical system. And I'm talking about the industrial business. So the cold storage of this world, the process facility, the medium temperature storage for fruit and vegetables, the low temperature freezing of equipment in a spiral or an inline tunnel, as an example, a blast freezer. This is another example. We have options on the table. So one of the very first option is to look at, we can do that with a transcritical system. You can look at it and you say, you know what, we can do it with an ammonia system as well. An ammonia system has their pros and then their cons, and the same thing with a CO2 system. But we have options on the table. So you sit down with the customer, you look at the plant, you look at the facility, and you start asking questions, and then you drill down the list and you're saying pros and cons and pros and cons, and which system do we take? And sometimes you can have people that's going to say, no, I just want an ammonia system. That's what I had all my life, and this is what I want to keep having. And other people is going to say, you know what, I have a synthetic refrigerant. I want to move to natural refrigerant. I never had ammonia in my life. I'm not sure I want to go that way. So then I'm going to try the CO2 system. And other people is going to say, you know what, I have ammonia. I'm comfortable with it. I love it. This is highly efficient. I'm comfortable. Everybody is trained. But I can understand that I can improve the design of my system by removing the ammonia from the plant, only keeping it in the mechanical room. And then what are you suggesting? Well, guess what? We can have an hybrid system, not only a CO2 transcritical system, we can go to a brine system or a Cascade system using a mix of ammonia with CO2. So then you look at it, and now you're not only stuck with one solution, you have 4, 5, 6, 7 solutions on the table.
And that's what's amazing about CO2. And not only that, you got more options, we're coming up with such great technology and ideas, like for heat recovery, heat reclaim, and air conditioning. Now we're going to see a massive shift because it's all about moving energy. And this is the way I'm talking now. You got to think out, just don't think of refrigeration. You got to think about moving energy. And this is the way I'm starting to learn how to talk, where I never talked 10 years ago or even 5 years ago. We're trying to move energy and use as much energy as possible, because those condensers, all those condensers out there right now in any synthetic system, just say it's a standard condensing unit, you're just throwing that energy away to the atmosphere. How do we utilize more of the energy? And I'm seeing this with CO2 systems.
And ammonia as well, Trevor.
Yeah, you're right, 100%.
We can do it with both, but you are so right. It's not ingrained, it's not entrenched in people thinking about, let me rephrase that. You move into a facility and you're with the plant operator, as an example, and show me your mechanical room. And then we're walking down the aisle, we're going to see the mechanical room. And then you say, show me your boiler room. And then we're going to the other end of the building, and you're wondering, you're paying 2 bills here, correct?
Yeah.
And let's go walk outside and let's just have a look at your condenser. Do you realize what you're doing? And a lot of people don't tie in the dot until they get both invoice. I have an electrical invoice, I have a natural gas invoice. And then you tell them, you know what, one of them could disappear.
They're like, what? What do you mean? What do you mean?
Yeah, exactly.
One bill?
Yeah, exactly. Only one bill. One could entirely, and not on top of that, if one disappeared, that means that you're probably going to reach your company goal towards a net zero approach and reducing your carbon footprint. Now, like me in Germany, how many heat pump, CO2 heat pump manufacturer have you seen?
There was many. There was many. And I was at
Oh,
a convention, and like there was talking about a little bit about heat pumps and VRFs and VRVs. And when I was at Chillventa, there was tons of them. And even I remember back in 2017 was the first time I seen a video from actually Daikin, where it does the VRF systems in CO2, but does all the refrigeration. So you're doing air conditioning, you're doing the refrigeration medium and low temp. And this was back in 2017. So these big manufacturers been working on this for a long time. Some of them were slower to the gate, but then when I would go to Chillventa, it was like they're everywhere. They were flying with it.
yeah,
It looked like.
yeah. They can purchase for their own home usage a CO2 condensing unit as an heat pump. Now, of course, their winter is not as worst as ours. And when I mean ours, I mean mine at least. And
Yeah.
even mine right now, the coldest we had so far is minus 11, minus 12, something like that. Now, that being said, and when you look at those manufacturers, in my mind, from what I know from CO2, I couldn't believe that CO2 could ever be used as a heat pump, because we know that when we are operating at warmer temperature outside the gas cooler, we're not as efficient as other refrigerant. Now you look at the way they're doing it, you start asking questions, you start reading, you start looking at what's on the market, and then you realize that if you put everything together and talking about a CO2 transcritical system, then you're going to the much higher suction. You have compressor made for higher suction temperature at the inlet. You already have the high discharge temperature. You're going into a gas cooling mode. So that means that, the difference between gas cooler and condensing, people still don't understand the difference. But when you really look into it and into the design of heat exchanger, you're going from a very high discharge temperature and then you're going down in temperature. Well, it starts to make sense to use that in a heat pump on a counterflow heat exchanger and warm up that water or that glycol, whatever, at a much warmer temperature than what we see. But then we have to bring back the CO2 at a colder temperature. So then they start adding parallel compression, subcooling, ejectors specially made. I don't know if you remember, but I've seen in one of the booth, one of the ejector that was about that big and that long. And that was for heat pump. I think it was a 2.5 megawatt heat pump, and the ejector was specially made for that. And you start reading and you start looking at it, and you see that they are achieving COP of excess of 3 or 4 using a CO2 heat pump at very high temperature.
And that's what's exciting about it. And because we're just starting, we're not 10 years into this, 20 years from now into this, designing this, because they weren't focused on this. Now that the growth that's happening, more people are investing money. And when you invest more money into technology, it starts to increase faster. And I've seen this with some manufacturers who waited and held back on doing CO2, and they started putting money in the last 4 or 5 years, and you should see how fast they ramped up. When you get a lot of money in research and development to really start to streamline their CO2 product line. And I'm seeing the growth happening very quickly.
Yeah. So if we put everything together, coming back into the industrial market, it's normal and frequent to see 40-ton, 50-ton evaporator in one single unit. So when you're used to do supermarket CO2 transcritical system, and the very first one you do, your coil, one of the evaporator is 40-ton, and you're telling that to the rack manufacturer, he's looking at you saying, okay, I think we're gonna have to be careful. Or you phone those evaporator manufacturer and you're asking for a 50-ton coil using DX CO2, it takes a while before he comes back to you. Now, those manufacturers are already up to the next generation that they know what they're doing. You can ask them 50-ton CO2 direct expansion. You can ask them CO2 pump recirculated. You can ask them for CO2 hot gas defrost. But keep one thing in mind, just a slight detail. The biggest CO2 transcritical compressor that you get, let's say at medium temperature, the I stage compressor will be maybe 30 ton, 40 ton at maybe 20 suction, something like that. One of the biggest, like the 90 kilowatt or something like that. So if your compressor is 30 ton and your biggest coil is 50 ton and you need to go in hot gas defrost, you got to think about it. And this is after that, the next step or the next thinking or the next choice that you have to make. Are you going CO2 transcritical? Are you going brine? Are you going Cascade? In any of those cases, the type of recirculation that you're going to have is a crucial decision. Are you going to go single circuit? And what I mean by that is one common temperature on the roof, for example, where you have one main pipe deserving every area. Or are you going with split circuit to every coil? If you're doing a 200-ton system, it's not so bad. If you're doing a 2,000-ton system with one central mechanical room, can you imagine the amount of pipe that you would need to cover maybe 50, 60 coil throughout the plant?
Yeah, I want to see one of these sites. That's what I want. I want to see one of these sites.
So in terms of approach, if you're going with a central system, you can have CO2 transcritical rack at 2, 3, 4, 5, and then you're going with individual circuit if your coil is going to be closely located. If you have a central engine room and then you're spread out in a very long distance, me personally, I would suggest that you might go with a brine system or a Cascade system where you're going to have a single circuit mains on the roof or inside the plant. And then you go to every coil and you're going to have to rethink about your hot gas defrost if you want to do hot gas defrost, and you're going to need to go with a 3-pipe or 4-pipe system. This is one thing to think about. But at the same token, you can also go further and say, forget about hot gas defrost. You can do electrical, which is what the European is doing majorly, but we're talking about energy here. Mm-hmm. So electrical is a choice, but is it really a choice? When you look at the size of those evaporator and then you have 80 kilowatt of electrical element for electrical defrost per coil. So it might not be a choice. The other choice is like, we're talking about energy, we're talking about heat reclaim, we're talking about reducing your carbon footprint. Why don't you do it hot glycol defrost? So if you do that, yes, you have more piping. Absolutely. Absolutely. But once the pipe are installed, what is your cost? Pumping power.
Yeah.
And if you're going to install those pipe for glycol defrost, why don't you move it to the office? Why don't you move it to the dock? Why don't you move it to the in-floor radiant, maybe for the parking lot? Why don't you move it to your neighbor? Why don't you start selling your energy to other people around you?
Yeah. And that was one thing that I had Danielle Clark from Cintra on here. It's from a company in the UK. And that's where I first learned about, that's how they build their industrial systems. They use glycol. They don't use, they don't do hot gas. They don't do electrical. They use glycol. And I'm like, that is just such a great idea, because once again, you're moving energy. And why don't we use that energy to, just like you said, heat the ground, heat the office, share it with a neighbor.
Exactly.
There's so many options.
Exactly. So if you look at industrial process, some cold storage, they only have cold storage in some offices. So I would say that the discharge of a CO2 transcritical system could certainly do the entire heating of that plant. If you move to a process facility where they would have much higher temperature need than just office space comfort, we're talking about clean hot water for sanitation in the process. Some people do have boilers, for example, for hydronic loop at 180, 200 degrees, as an example, some as a pasteurization process, then you can start thinking about, I can go with a CO2 transcritical system for the refrigeration need of the plant, and then I can add a stage of CO2 heat pump for the rest of the process, as well as I can do it with a central ammonia plant, with an ammonia heat pump for the hot temperature process heat pump side, and then I can cool down CO2 that I'm pumping throughout the plant. So why would I do that? I would go with ammonia because the equipment right now in the market is much larger, and it's more industrial. And then when I'm saying that, I'm not negative. I see it in a different approach, that the equipment is built in a certain way that it's large size. We're talking motors of 500 horsepower all the way up to 1500 horsepower. The day I'm going to see a CO2 transcritical compressor using a 1500 horsepower motor, I think I'll retire that day. I'll be an happy guy.
It's not far away.
I don't know.
I don't think it is. Well,
I
I
don't
know
know.
that all the big compressor manufacturers like that, the screw manufacturers like Mycom, Vilter, Sabro, they're working on this stuff. They are working on this stuff. So
and
people don't think it's getting big compressors. They're coming. Like,
exactly.
they're not far off.
And when it's going to be ready to the market, you're going to walk into a mechanical room and you're going to say, this is an industrial installation. You can see the equipment more robust, bigger, way less compressor. Again, I love CO2 transcritical, but in my mind, if I'm going to have like 40 CO2 transcritical compressor in the mechanical room for myself, I'm not sure it's the best approach. Honestly, right now, I'm not sure it's the best approach. I would like to see bigger machine. And to me, it would make no difference if it would be ammonia or CO2. What I like to see is like CO2 going in the plant. So I'm removing ammonia from the plant. I'm pumping CO2. And when you start thinking about it, pumping CO2, what does it mean? People's going to say, oh, we're talking about high pressure. And they see that as a bad thing. Well, when you're doing low temperature refrigeration, actually having more pressure, it's such a wonderful thing. If you're doing a minus 40 installation, as an example, and you're using ammonia, you're going to be running under vacuum. If you are 100 feet away and you're trying to bring back a mixture of gas and liquid, it's going to cost you something, which is called a pressure drop. You're already running under vacuum. You're trying to bring that back to the mechanical room. You need to run your compressor way lower in temperature just because of that pressure drop. If you're losing 3 psi when you are already under vacuum, it's going to cost you money. If you do that with CO2, and you're running at very low temperature, but your suction pressure is 200 psi, and you're losing 5 psi, big deal. You know what? Big deal. You just lost 0.6 degrees.
Huge.
You know, this is one thing. Pressure drop. Running on high pressure gives you the advantage of pressure drop when you're doing low temperature. CO2 is, we know about the specific volume and density of CO2. Your pipe size is going to be probably half of any other refrigerant. So that means pipe support, structure, insulation. Because it's high pressure, when you're doing CO2 transcritical supermarket and smaller size refrigeration, it's a no-brainer. Everybody use copper tube. When you're doing industrial refrigeration and you get into 3, 4, 5, 6-inch piping, we're doing stainless steel. If you're installing stainless steel, high pressure design, everything is TIG weld, everything is high quality, Schedule 40 or Schedule 10, how long do you think those pipes going to stay there without even like worrying about it?
Longer in the building.
Exactly. Even if the insulation is made, I wouldn't say cheap. I was just about to use that word. But let's say there's an issue with the insulator. on the piping, and you do have a failure in the piping, are you at risk of compromising your steel pipe with rust and eventually failure? You're not going to see that.
It's just these little tips and tricks that people aren't aware of yet. Like that right there is, and we know that copper is continuing to get more and more expensive. I don't know the prices of stainless steel versus copper, but I'm sure it's stainless steel is probably cheaper in some applications. And then
Stainless steel is going to be cheaper. So the big difference will be, of course, the price of welding the piping.
yeah, but I know contractors already that do CO2, and they got a full team of welders on the. So it's a new, that they're just working with the installers, the refrigeration installers, and they have teams of guys going out every day that know how to do this. So yes, maybe it's not you as the technician where you're usually brazing in on these big applications, but or fixing them, but we're seeing this technology change, and there's nothing wrong with that. I think that's great to have these new skills, and then you can learn these new skills if you want to get into that side to TIG welding and stuff. If you love to pipe, that's it. It's a new skill, a new option. There was no option like that when I was in the field.
Again, thinking about big installation, if you have seen some, I've seen so many times in my career, like 8-inch, 10-inch, 12-inch, even 16-inch suction piping. So if you think about the people installing those piping in the mechanical room or on the roof, and you ask your construction team, why don't you move that 10-inch pipe steel, on the roof, and you go put it on the rack and you get it ready for the welder? How many guys you think you need to move that 10-inch pipe? If you switch the very same duty, but instead of going synthetic or ammonia, you're going to CO2, and now it's no longer a 10-inch pipe, but it's a 5-inch pipe.
No, it's huge. And I've been hearing this more and more from different contractors as they get into bigger size equipment. Is like, it's really reducing even the labor costs and the amount of guys that you need for the install sometimes. And I don't know if it's exactly that in the industrial side, but I even heard this in the commercial side, where they're really being able to ramp some of the production up and the installation up with these new ways of going about it.
Yeah, exactly. Totally.
And I love learning about this because this is why I love doing this, and I thank you for sharing your knowledge with us, because more people need to understand that there's options, and these are options, and it could benefit you. And like you said earlier, you got to check the cost benefit analysis. You do need a break. You can't just go in and say, let's do CO2. You can't be doing that because it may not be right for that specific application. You might want to go with ammonia or something else. But it's so important to do these cost benefit analysis, break it down, understand what your customer is looking for. What is the best solution? And another thing too that we haven't really talked about is depending on where you're at, and I think you kind of mentioned where you're at in the world. Maybe at this point you don't have the skill, you don't have the level of skill for someone to work on that equipment, and that's fair. But I see more and more training. I'm training CO2 all the time. I see more and more people talking about CO2. So I'm going to see more and more trainers over the years is going to happen to help develop and help the industry out. And then you're going to see it continue to grow, because I have talked to end users and I had talked to contractors. They're just like, well, we don't have people that we can rely on to work on this equipment at this point. And that's some of the hesitation of some customers. They want to go with it, but they're hesitant because they feel that they might not have someone to work on it. But what I'm starting to see the change is that more and more people are starting to work on it. We'll see contractors kind of like you guys can go and work on that. It's not like, oh, we got a CO2 site, we need some service, we need to install. Okay, we got a team, we can send them.
Yep.
Where like
exactly.
25 years ago, that wasn't the case. You had to find a select few people or a select person to go out. So there's more and more options, and we're going to see this continuing to grow. There's thousands and thousands of commercial installations around North America, and hundreds and hundreds, I'm sure, industrial applications. And when those numbers start to increase, we need to increase the education, and we need to we're going to see a bigger reach with CO2.
Oh, absolutely. Well, we already have seen large installation that has been made with CO2. Ourself, we are over 20 something industrial installation. CO2 transcritical, CO2 brine, CO2 cascade. We've done it all. We've done it all.
Nice.
And we know also other people that has done large system. I know a couple I've seen in US, really, really large system that has been done with CO2 transcritical.
Yeah. And I continue to hear more. People reach out to me all the time. We're working on this project. We're trying to get this one off the ground. We're working with customers on this one. And this is from all sides of applications. Like I said, from light commercial to industrial. And we're going to continue to see the growth of this. I'm super excited because the next 10 years is going to be amazing, because a lot of people, like even me, I used to think, oh, 1 year, 2 year ahead. We don't think like some other countries where they're planning 50, 100 years ahead. Now I'm thinking 10, 15, 20 years. CO2 is going to be it's going to be in the trade schools. You know what I mean? Right now, we don't even, not many schools across North America, even across the world, don't talk about it, because I talk to other countries, they don't talk about CO2. But as it continues to ramp up, we're going to grow the knowledge. We're going to share that knowledge with more people. And we're just going to get, I know we're going to get better at CO2 refrigeration.
So one of the typical example that we can have is an end user which has an R22 low temperature system, as an example. So let's say 500 ton, 600 ton R22, real industrial system with a screw compressor, sometimes booster and high stage, sometimes single stage screw compressor. And now they want to upgrade, change their system, obviously, because they had a leak and it costed them $150,000 of replacing R22. So what do you do? If you're somebody like that, what do you do? You're looking at synthetic refrigerant drop-in. Are you really going to change your R22 for R449 in a 600-ton system running at -40? Are you going to do that? That's one of the options. That's one solution. Are you going to do that? The other option is you get rid of everything and you're going with 2, 3, 4 transcritical rack running at -40, and you need to change the coil. And then you're going with single circuit and you have gas cooler on the roof, and it's going to cost you so much money. And you also have the choice of saying, you know what, I have an R22 system. It's not that old. I like those screw compressors. Why don't I change the R22 inside those screws and I move it to ammonia, as an example? So we can retrofit those R22 screws, moving them from synthetic refrigerant to ammonia. And then you're going with a CO2 cooler, called a Cascade cooler, and then you go with a CO2 recirculator, and you change those evaporator, and you change the piping, and this is another solution on the table. And you're going to look at your energy bill, between your R22 system and this approach, and you're going to be impressed. And if you look at your energy bill, if you're going with a CO2 transcritical system, and you pay attention to where you are located and you make the right choice on the condensing side, you will certainly have a very nice surprise when you get your energy bill as well.
Yeah. And I love this. And I love that this is what we need to be talking about more, because I know most customers don't know they have this many options. The project managers, the salespeople, a lot of them, they don't know all these options. So how can you offer that to your customer if you don't know it either? And this is all about the knowledge, understanding that there are this many options. And another thing too is like acceptance of it, because there are still people that are not accepting that CO2 is coming or is here, but it is, as we've seen, as we were in Chillventa, as we talk about week over week. We've almost been doing this show for over almost a year now, and continue to hear of more applications being installed around the world from all the different people, and I love that, and I really appreciate it. Benoit, I want to do another event, another talk with you, because these are always so fun. We share so much great knowledge. I learned so much from you, because even here I got a page of notes, and I could write even more and more. But how can people get a hold of you, get a hold of your company, learn a little bit more about what you do? If they want to learn more about industrial CO2, how do people get a hold of you?
Well, the first thing is, of course, social media. You're probably the best example between you and me. I'm still old generation, I guess, and you are only like social media. That's great. I love it. I remember when I asked for your business card and you said, business card, what's that? Kind of.
Yeah.
So I can be reached, of course, on LinkedIn, social media. Luckily, I'm on YouTube, and that's because of you. Thank you very much, where I can be reached. Cimco Refrigeration, pretty well known. We have an incredible site. Please go check it at cimcorefrigeration.com. Marketing's doing a wonderful, wonderful work. We have tons of new publication, videos, stuff explaining, all the industrial refrigeration, net zero approach, heat pump. This is probably the best place to reach me. If you're thinking about doing something, you would like to have some good information, you would like to discuss about it, please give me a call. I'll be more than happy. And I would also like to share, if you allow me, a recent job we did. As you know, Cimco is very well involved into ice rink refrigeration as well. And we have replaced in United States, in a big stadium, it was a 15,000 seats in Pennsylvania. They had an industrial R22 system on a good old Mycom recip compressor with evaporative condenser outside. No, excuse me, it was cooling tower on this installation, water-cooled condenser, shell and tube water-cooled condenser inside, big shell and tube flooded chiller on R22. And they decided to change 150-ton system, and we went with a CO2 Transcritical system. And we convinced them to change their cooling tower to go with the gas cooler, adiabatic gas cooler outside. So it was a big investment at the beginning. And it would have been simpler to go with a cooling tower, and we convinced them to go with a gas cooler because we believed it was going to be the best energy efficiency that they could achieve. It's been running since September. So the very first month, September, was a reduction in energy bill by 11%. But the most interesting part was the reduction in water consumption. Since then, September, October, November, December, we just got the bill of December, 37% lower than the previous year, and $20,000 in saving water. Wow. Just to let you know, from R22 to CO2 Transcritical. In Pennsylvania. So in my head, there's always people saying, oh, it's not going to work in US CO2 Transcritical. Well, guess what? It does work. It does work really well.
I love that. Benoit, thank you so much for taking the time. Everyone, go check out that website. Thank you so much for taking the time. Can't wait to see all of you at the next CO2 Mondays. Thanks, everyone. Thanks, Ben.
Thank you, Trevor. Bye-bye.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.